Ashe. My dear friends, I am your royal narrator, Queen Magical Melanin, extending a warm greeting to all gathered for our basic applied electronics information session produced by our esteemed elder Baba Jelani Bomani Dembe, the brilliant mind behind Majestic Mind Matters University, and the mandatory Mental Liberation series, eagerly enriching our learning journey. Today, we venture into the world of basic applied electronics, where circuits and currents intertwine to unlock endless possibilities. Let us embark on this enlightening adventure together, exploring the wonders of technology and innovation under the guidance of our distinguished elder Baba Jelani Bomani Dembe. Welcome to a transformative experience that will ignite your curiosity and mastery in the field of applied electronics. So pay close attention and take plenty of notes to prepare you for possibly answering a few easy questions near the end of the session. In this basic applied electronic information session, you will be introduced to the demultiplexer. Applied electronics technicians play a crucial role in today's society by ensuring that electronic systems are functioning properly and efficiently. One important component that they need to be well-versed in is demultiplexers. Demultiplexers are essential devices in electronic circuits that play a crucial role in signal processing and data transmission. In this essay, we will explore what demultiplexers are, how they work, and why applied electronics technicians need to have a good understanding of them. Demultiplexers, also known as DEMUX, are electronic devices that take a single input signal and distribute it to multiple output signals. They are the opposite of multiplexers, which combine multiple input signals into a single output signal. Demultiplexers are commonly used in digital communication systems to separate multiplex signals for individual processing. They are also used in data transmission systems to route data to different parts of a circuit or system. Applied electronics technicians play a vital role in designing, building, and maintaining electronic systems in various industries. One key component that technicians need to be well-versed in is demultiplexers, also known as DEMUX. Demultiplexers are essential electronic devices that play a crucial role in distributing a single input signal to multiple output signals. Demultiplexers combine multiple input signals into a single output signal. In digital communication systems, where multiple signals need to be transmitted simultaneously, multiplexers are used to combine these signals into a single stream. The demultiplexer at the receiving end then separates these multiplex signals back into their individual components for processing. This process of multiplexing and demultiplexing is commonly used in telecommunications, satellite communication, and data networking. One of the key applications of demultiplexers is in data transmission systems. In a data transmission system, demultiplexers are used to route data to different parts of a circuit or system. For example, in a computer network, a demultiplexer can be used to direct incoming data packets to the specific destination address they are intended for. This helps in the efficient and accurate transmission of data across the network. In addition to data transmission systems, demultiplexers are also commonly used in digital audio and video systems. In these systems, a demultiplexer helps separate the audio and video signals that are multiplexed together during transmission. This allows for separate processing and decoding of the audio and video signals, resulting in high-quality output for the end user. One important aspect that applied electronics technicians need to understand about demultiplexers is their internal structure and operation. Demultiplexers typically consist of multiple input lines, a single data input line, and multiple output lines. The data input line carries the input signal that needs to be distributed, while the input lines select which output line the signal should be directed to. By controlling the input lines, technicians can route the input signal to a specific output line, allowing for individual processing or distribution. Another key concept that technicians need to be familiar with is the timing and synchronization requirements of demultiplexers. In digital communication systems, timing and synchronization are critical for the accurate separation of multiplex signals. Demultiplexers need to be able to synchronize with the incoming signal and correctly identify the individual components within the multiplex stream. Applied electronics technicians need to understand the timing requirements of demultiplexers and ensure that they are properly configured to handle the incoming signals. Furthermore, Technicians should also be aware of the different types of demultiplexers available and their specific applications. There are several types of demultiplexers, including binary demultiplexers, octal demultiplexers, and hexadecimal demultiplexers. Each type of demultiplexer is designed to handle a specific number of output lines, depending on the complexity of the system and the number of signals that need to be distributed. Demultiplexers are essential electronic devices that play a crucial role in digital communication systems, data transmission systems, and audio-video systems. Applied electronics technicians need to be well-versed in the operation, structure, timing requirements, and types of demultiplexers to effectively design, build, and maintain electronic systems. By understanding the fundamentals of demultiplexers, technicians can ensure the efficient and accurate distribution of signals in electronic systems, leading to reliable and high-quality performance. The primary function of a demultiplexer is to select one of several input channels and direct it to a specific output channel. This can be achieved using various techniques, such as addressing, time division, or frequency division. Demultiplexers are critical in applications where data needs to be routed to different destinations, such as in telecommunication networks, computer networks, or industrial control systems. As an applied electronics technician, it is important to have a deep understanding of demultiplexers and their primary function in electronic systems. Demultiplexers play a crucial role in routing data from one source to multiple destinations, making them essential components in a wide range of applications, from telecommunications to industrial control systems. The primary function of a demultiplexer is to select one of several input channels and direct it to a specific output channel. This process is typically achieved using various techniques, such as addressing, time division, or frequency division. By selecting the appropriate technique, demultiplexers can effectively route data to different destinations based on specific criteria. In telecommunications networks, demultiplexers are used to separate multiplex signals into their individual components, allowing for the transmission of data to multiple destinations. For example, in a telephone network, demultiplexers are used to route incoming calls to specific phone lines based on the dialed number. This process is crucial for ensuring that calls are properly connected to the correct destination. In computer networks, demultiplexers play a key role in data routing and packet switching. When data packets are received at a network interface, demultiplexers are used to direct the packets to the appropriate destination based on their destination address. This ensures that data is efficiently routed to the intended recipient, helping to optimize network performance. In industrial control systems, demultiplexers are used to route control signals to various devices, such as sensors, actuators, and motors. By using demultiplexers, technicians can effectively manage and control multiple devices within a complex system, ensuring that each device receives the appropriate signals for operation. Demultiplexers can also be used in conjunction with multiplexers to create more complex routing systems. By combining multiple demultiplexers with a multiplexer, technicians can create a system that can route data from multiple sources to multiple destinations, providing greater flexibility and control over data flow. It is important for applied electronics technicians to have a thorough understanding of demultiplexers and how they function in electronic systems. By understanding the primary function of demultiplexers and the various techniques used for data routing, technicians can effectively design and troubleshoot electronic systems that rely on demultiplexers for data routing. In order to effectively work with demultiplexers, technicians must also be familiar with the various types of demultiplexing techniques, such as addressing, time division, and frequency division. Each technique has its own advantages and disadvantages, and technicians must be able to select the most appropriate technique based on the requirements of the system. Furthermore, technicians must also have a solid understanding of the various components and circuitry involved in demultiplexers, such as decoders, flip-flops, and logic gates. By understanding how these components work together to route data to specific destinations, technicians can effectively troubleshoot and maintain demultiplexer circuits in electronic systems. Demultiplexers play a critical role in electronic systems, enabling the routing of data from one source to multiple destinations. As an applied electronics technician, It is essential to have a thorough understanding of demultiplexers and their primary function, as well as the various techniques and components involved in data routing. By mastering these concepts, technicians can effectively design, troubleshoot, and maintain electronic systems that rely on demultiplexers for efficient data routing. Applied electronics technicians need to have a good understanding of demultiplexers because they are used in a wide range of electronic systems and devices. By understanding how demultiplexers work and how they are integrated into circuits, technicians can troubleshoot and repair electronic systems more effectively. They can also design and build circuits that require demultiplexing functions, such as data acquisition systems, digital signal processors, and communication systems. One key aspect that technicians need to know about demultiplexers is their operation principle. Demultiplexers typically have a select input that determines which output channel the input signal is directed to. When a specific channel is selected, the demultiplexer routes the input signal to that channel while blocking the other channels. This allows for the separation and distribution of data or signals to different parts of a circuit or system. Technicians also need to understand the different types of demultiplexers available and their applications. Some demultiplexers are designed for specific data formats, such as binary or hexadecimal, while others are more versatile and can handle multiple data formats. There are also demultiplexers with different numbers of output channels, ranging from 2 to 16 or more. By knowing the capabilities and limitations of different demultiplexer types, technicians can choose the right device for their specific application. Another important aspect that technicians need to consider is the speed and performance of demultiplexers. As data rates in electronic systems continue to increase, demultiplexers need to be able to handle high-speed signals without introducing errors or delays. Technicians need to ensure that the demultiplexer they choose can meet the bandwidth and latency requirements of their system. They also need to be able to troubleshoot and optimize the performance of demultiplexers to ensure reliable operation. In conclusion, demultiplexers are essential components in electronic circuits that play a crucial role in signal processing and data transmission. Applied electronics technicians need to have a good understanding of demultiplexers to effectively design, troubleshoot, and repair electronic systems. By knowing how demultiplexers work, the different types available, and their performance characteristics, technicians can ensure the smooth operation of electronic systems and devices. Demultiplexers are just one example of the many important components that technicians need to be familiar with in the field of applied electronics. Thanks for your participation in this special Majestic Mind Matters University Basic Applied Electronics Information session. I am your royal narrator, Queen Magical Melanin. Here is a special message from our esteemed elder Baba Jelani Bamani Dambe, the brilliant mind behind Majestic Mind Matters University. To all applied electronic technicians, he wants you to know this. Your participation with Majestic Mind Matters University has been invaluable. Your expertise and commitment to excellence has elevated our research and knowledge in the field of applied electronics. Thank you for choosing Majestic Mind Matters University as a trusted source for your valuable applied electronics information to aid to your success with this basic applied electronics information session titled Introduction to the Demultiplexer. Stay woke. Ashe.